Okay, so we've been dealing with simple circuits that just had one resistor or a total resistance. So let's talk about what happens when we have um, resistors in parallel and resistors in series. But first, let's review what we know. Okay, so we learned that we're going to be dealing with devices that are ohmic, which means the resistance is constant. And as you apply different voltages, the current increases directly proportional to the voltage change because the resistance is constant. That's called Ohm's law. We also learned that devices have power ratings. You can find it using these equations if you want to. And we know that voltage is measured in volts, current is measured in amps, and resistance is measured in the ohm. And power is measured in a joule per second or a watt. So what is a series circuit? Remember from our discussion of capacitors that a series circuit is one in which, when you look at it, you identify the negative terminal and the positive terminal of battery, and you trace the current from positive to negative. In this case, it's going around clockwise, and there's only one loop of current. So all of these devices are going to have the same current. R1, R2, and R3 will all have the same current. And really, that battery is not really seeing three separate resistors. It's like the resistors are acting like one resistor. And that one resistor is called the equivalent resistance, or the total resistance, REQ. So let's talk about how we find the total resistance. Before that, though, let's remember that if we were to think about the potential difference over the battery terminals, we connected a voltmeter here. We would measure the voltage to be whatever the voltage is of the battery. And if we measured it here over here, it would be the same as whatever it is over the battery. So that means that the total voltage of all three of these is going to add up to be the voltage of the battery. So resistor 1 will have its own voltage. Resistor 2 will have its own voltage or potential difference. And R3 will have its own voltage or potential difference. And that the total voltage of the battery is equal to the sum of each of these. Let me get that back up. Sorry about that. So the total voltage, which is the voltage of the battery, is going to be equal to V1 plus V2 plus V3. So these are the rules that we know about series resistor circuits. They have the same current, and their voltages add up to be the voltage across the total of them. In this case, the battery. So let's use that information. We know that in this case, here's the negative side, here's the positive side, so here's our current I, and it's going all the way around this circuit. So these are all going to have the same current, but they're going to have different voltages across them. And that the total voltage of the battery, V, is equal to the sum of those. We also can apply Ohm's law to each of these, right? V1 would be equal to whatever the current is in the total circuit times R1. V2 is I times R2, and V3 is I times R3. So that means that V equals R1I plus R2I plus R3I. And notice that I can be pulled out, and that leaves us with R1 plus R2 plus R3 times I. And since V is the total voltage of the circuit, and I is the total current in the circuit, then R1 plus R2 plus R3 has to be the way that we calculate the total resistance of this circuit, or the equivalent resistance. So the equivalent resistance for 3 resistors in series is just literally R1, R2, and I3. Let's look at a sample problem. So let's look at this problem. If I wanted to figure out the current in this, I know that the voltage of the circuit is equal to the total resistance times the current in the circuit. V equals IR, right? So if I'm looking for that, then I need to first find the equivalent resistance. In other words, I'm going to simplify this down to something a little simpler, to just a 1 resistor circuit. Then I can just use Ohm's law the way I know how to use it, and life is easy. So I need to find Req. Well, Req is simply 3 kiloohms plus 10 kiloohms plus 5 kiloohms. So that would be 18 kiloohms. And the voltage is 9 volts. So if I want to find the current, right, I is going to be equal to whatever V is divided by Req, which is 9 volts, divided by 18 e to the 3 ohms. So I need to make sure I put it out of that scientific notation and put it in, replace the K with e to the 3. So if I do that, I get 9 divided by 18 exponent 3, and that's 5 e to the negative 4, to the negative 4 amps. Now, you can double check that if you multiply 5 e to the negative 4 times 3, and then times 10, and then times 5, these numbers will add up to be 9 volts. All right, let's go to the next video.